The open-weight arms race. The largest fully open-weight model just dropped, and it isn't from a Silicon Valley lab. YuanLabAI's Yuan 3.0 Ultra is a 1010 billion parameter mixture of experts model with 68.8 billion active parameters per forward pass. And every weight, the technical report, and training details are published under a permissive license. The headline innovation is LAEP layer adaptive expert pruning, which the team says cut the original 1.515 trillion preliminary checkpoint by 33%, while boosting pre-training efficiency by 49%. Whether you trust the benchmarks or not, the sheer audacity of releasing a trillion-parameter MOE with full 16-bit and 4-bit weights is a statement. The open-weight frontier is not slowing down. The model targets enterprise RAG, complex table understanding, and long document analysis rather than the coding benchmarks everyone else chases, which is a refreshing change of pace. Community reactions range from excitement to sticker shock. Running even the 4-bit version requires infrastructure that makes consumer GPUs weep, with one commenter noting that 16XA100 rental runs $28.61 hour. But the LAEP pruning technique itself is worth watching. If you can train at 1.5T and prune to 1T with quality preservation, the open-weight community may have found a new playbook for training time efficiency. On the inference side, llama.cpp is on the cusp of native NVFP4 support via PR number 19769. The initial merge adds the ggml typ NVFP4 block struct, conversion logic for NVIDIA ModelOpt models, and reference CPU/ARM Noon implementations. But no CUDA kernels yet. That last detail matters. Until someone writes the CUDA backend targeting Blackwell's native FP4 tensor cores, this is CPU emulation, not the promised 2.3x speed boost. The key distinction from standard Q4KM or IQ4XS quants is that NVFP4 is designed for models trained in that format via ModelOpt, not for post-training quantization. When the CUDA path lands, Blackwell owners should see both quality and throughput advantages over traditional 4-bit quants. StepFun continues its quiet streak of open releases with Step 3.5 flash base and a mid-train checkpoint, plus training code and a promise of SFT data soon. The kind of transparent release cadence that earns community trust. Meanwhile, the uncensored model cottage industry keeps producing. A QWEN3.59B aggressive GUF hit 0 refusals across 465 test prompts with 0 reported capability loss. Leveraging the new hybrid gated DeltaNet, plus softmax architecture with 262K native context and multimodal support. The 27B and 35B variants are reportedly in progress. Securing the Agentic Stack. If AI agents are going to call APIs, manage credentials, and act on behalf of users, someone eventually has to formalize how they authenticate. An IETF Internet Draft published March 2, 2026, by authors from De Facto Security, AWS, Zscaler, and Ping Identity does exactly that. Draft Chloris Agent Auth 00 proposes treating AI agents as workloads under the existing WIMSE workload identity in multi-system environments architecture and composing OAuth 2.0 transaction tokens and HTTP message signatures into a coherent agent auth framework. The document explicitly avoids inventing new protocols, instead mapping the agent lifecycle identity provisioning, credential attestation, transport layer and application layer authentication, delegated authorization, human-in-the-loop gating, cross-domain access, and monitoring/remediation onto standards that already exist. The gaps it identifies, like how to handle tool-to-service authorization when an agent chains MCP calls across trust boundaries, are precisely the unsolved problems that matter. This is the kind of boring, essential infrastructure work that prevents the agent ecosystem from becoming an authentication free-for-all. On the defensive tooling side, a detailed walkthrough of running Claude code inside Nono, an open-source kernel-level sandbox, on Red Hat OpenShift demonstrates both the promise and rough edges. Nono uses Linux landlock and macOS seatbelt to enforce irreversible file system restrictions at the syscall level. No escape hatch, no API to widen permissions after they're set. The walkthrough reveals real friction. Claude code built on bunseg faulted because the default Claude code profile didn't whitelist /d, ev, /u random/d, ev, /null and /d, ev, /t, why that buns JSC engine needs its startup. Once patched with explicit, allow red flags for those pseudo devices, the sandbox successfully blocked pkexec ls/root attempts, caught an incorrect kubeconfig path, and let Claude deploy a Flask app to OpenShift with proper auditing and atomic rollback support. The immutable audit trail with Merkle root verification is particularly compelling for enterprise compliance. Without the sandbox, Claude happily ran pixec ls/root after prompting for authentication. A reminder that the agent permission model today is essentially whatever the user approves in the moment, which is not a security model at all. Zero-day clock tracks the accelerating collapse of time to exploit, the gap between vulnerability disclosure and first confirmed exploitation. Using 3,500-plus CVE exploit pairs from sysakev and vulncheck, the median TTE fell from 771 days in 2018 to 4 hours in 2024. By 2026, 67% of exploited CVEs are 0 days. The site pairs this data with a historical timeline of how AI accelerated the collapse, a searchable CVE explorer, and a 10-point call to action. From vendor liability and memory-safe mandates to open-source defense and machine speed regulation. Backed by 40-plus signatories including Schneier, Adkins, Jeff Moss, and Halvar Flake. More. ZeroDayClock.com.
The Vibe Coding Reckoning. A provocatively titled essay argues that the word missing from the LLM discourse is forgery. The core claim: LLMs allow individuals to produce forgeries of their own potential output faster than they could make it themselves, and the only way to separate gold from slop is source attribution during inference. A technical impossibility with current architectures. The piece draws a line from controlled appellation cheese, where geographic origin protects quality and expertise, to open source code maintenance, where slop PRs from resume padding vibe coders are forcing projects to ban or ignore AI-generated contributions. The observation that experienced engineers who adopt AI coding still produce highly embarrassing goofs rings true for anyone who's reviewed a PR where the thought process was clearly none at all. The proposed fix: making backpropagation auditable and weights attributable, is a research moonshot, but the diagnosis is sharp. A technology that cannot tell you where its information comes from is by design sloppy. That diagnosis gets empirical support from a candid founder's conversation about the massive discrepancy between people's AI worldviews on software engineering. One founder described seeing diametrically opposed LinkedIn posts, one bragging about 10x commit rates, another calling AI output a mountain of junk, and not knowing which universe is real. The answer, they conclude, is both. AI produces genius-level fixes on prototypical problems, but hallucinates entire background processes for anything with actual stateful logic. One participant recounts an AI that concluded, entirely from thin air, that a get transitions function only returns automated transitions, then started tearing the codebase apart based on that hallucination. The session's verdict: software engineering is too large to fit into the context window of an AI. The AI is always running with tunnel vision, like a guy driving a tank. A detailed video analysis puts numbers to the adoption gap. While 90% of engineering teams nominally use AI in their workflow, only 51% of professional developers use AI tools daily per Stack Overflow. A full 76% of executives believe their teams have embraced AI, while only 52% of engineers agree. And 21% of AI coding licenses remain underutilized. Enterprise adoption faces corporate red tape, procurement processes, security reviews, and senior engineers who rightly distrust hallucination-prone tools for production-grade systems. The evolution from prompt engineering to context engineering to intent engineering, where developers define architecture, success criteria, and validation strategies while delegating only the typing, looks less like engineering extinction and more like engineering with a very demanding junior developer. Anthropic's own CEO says software engineers could go extinct in 2026. The creator of Claude Code says great engineers are more important than ever. That contradiction from within the same company tells you everything about the incentive structures at play. Context engineering. From prompts to compiled specs, Abnormal AI's engineering team has gone further than most in operationalizing spec-driven development. Their system starts with 4 markdown files in the repo: architecture.md, legal.md, a security.md, and a spec template that encode organizational constraints. A CLI built on the Claude Code SDK ingests anything from a full PRD to a few bullet points and generates a 2-audience technical plan. Skimmable architecture decisions for human reviewers up front, detailed function signatures, and verification checklists for agents in the back. The clever bit is the feedback flywheel. A Zoom bot records every design review. An agent processes recordings plus Slack threads and PR comments weekly and generates a PR updating the system files. Every review trains the system, not just evaluates a single plan. Non-engineers, PMs, data analysts, are now self-serving production changes through this pipeline. They're open sourcing the template as a Claude skill. The context compilation approach takes a different path to the same goal. Instead of stuffing a million tokens into a context window, one practitioner built a recursive language model gateway that loads an entire repo into a repo workspace, writes programmatic code to walk, slice, and search it, then hands only a tiny compiled context pack to the downstream model, treating tokens as CPU, not storage. The result: Claude and Minimax suddenly act like they've been on the project for 2 years, without the architecture drift that comes from trying to grep across an entire codebase inside a prompt. Sane, an open-source agentic deep search orchestrator, attacks the context quality problem with 20 specialized agents in a 3-phase gated pipeline. Phase A discovers evidence across 9 domains. Phase B deploys a dedicated skeptic agent to challenge every claim while a referee resolves conflicts. And Phase C runs adversarial red team analysis with calibrated confidence scores. Validators at each gate push back for more evidence or stop the pipeline with a partial result and a clear label. The adversarial architecture is the right instinct. If context is king, bad context is poison. On a complementary note, the Semantic Anchors project catalogs 46 well-defined terms and frameworks, from TDD, London School to clean architecture, that serve as shared vocabulary between humans and LLMs, compressing complex context into tokens that reliably activate the right knowledge domains. Agentic tooling levels up. Simon Willison's new guide on agentic engineering patterns distills hard-won lessons into a compact reference for getting the best results from Claude Code and OpenAI Codex. The framing: writing code is cheap now, and hoard things you know how to do. Captures the shift from treating code as precious output to treating it as disposable intermediate artifact. The guide joins a growing library of practitioner-driven pattern catalogs that are quietly becoming more useful than vendor documentation. Anthropic's new Playground plugin for Claude Code lets users build custom interactive HTML tools. Sliders, color pickers, click regions, approve/reject buttons that generate natural language prompts at the bottom. Draw rectangles on a UI screenshot to create location-aware instructions. Paste a document for inline critique with approve/reject per suggestion. Dial in spacing and typography with live sliders and copy the resulting spec. 6 templates ship built in, and someone has already wired one up to send feedback directly back to Claude via an MCP server, closing the loop entirely. OpenWebYV 0.8 Thix 6 ships terminal integration that goes beyond tool calling. It's a full Linux plus Python sandbox Docker container with File Explorer, upload/download, and inline editing in the sidebar. The release also addresses what users had been calling a bloated mess with substantial front-end and back-end performance improvements. Eliminated CPU/memory hogging, fixed memory leaks, and smoothed token streaming. The comment that OpenWebY should find courage to remove legacy parts like pipelines/pipes/filters and focus more on skills suggests the project is at an architectural inflection point. World Intelligence MCP server pushes the MCP ecosystem into ambitious territory. 68 tools across 27 intelligence domains. Financial markets, conflict tracking, military flight monitoring, cyber threats, space weather, disease outbreaks, shipping stress indices, and more. All from free public APIs with per-source circuit breakers and a live ops center dashboard. It evolved from a focused threat intel MCP server into a comprehensive AgentB platform, which is exactly the trajectory the MCP ecosystem needs. Specialized servers that do one vertical extremely well. For developers building their own integrations, the public APIs repository remains the canonical directory of free APIs across 40+ categories. Building voice agents that don't suck. A Hacker News show HN details building a sub-500 milliseconds latency voice agent from scratch, and beating Vapey's equivalent setup by 2x. The architecture is deceptively simple. Twilio streams audio to DeepGram's Flux, which combines transcription and turn detection in a single model. End-of-turn triggers an LLM, TTS streaming pipeline, and Bargen's propagate cancellation to all components simultaneously. 3 optimizations made the biggest difference. First, keeping TTS WebSocket connections warm pre-connected pool shaved about 300 ms. Second, deploying the orchestration layer in the EU region near the API endpoints cut latency in half. Geography is a first-class design parameter. Third, swapping GPT-4o Mini for Grok's Llama 3.370b dropped first token latency to about 80 ms faster than a human blink, bringing end-to-end response time to about 400 ms. The author's latency measurements are worth internalizing. Grok's Llama 3.370b delivered about 80 ms time to first token, which accounts for more than half of total latency. First token latency is the metric that actually matters in voice. Everything downstream TTS synthesis, audio buffering can be pipelined, but nothing moves until that first token arrives. The lesson: voice agents are an orchestration problem. And understanding the pipeline end-to-end lets you outperform abstraction layers that hide the complexity. For teams evaluating Vapey, 11 Labs, or rolling their own, the takeaway is clear. Measure TTFT, co-locate your services, and keep your WebSocket connections warm. When agents go kinetic, a military training presentation, marked UN's classified / for training US only, lays out how U.S. Special Operations Forces are framing agentic AI. The document maps the ODO loop, observe, orient, decide, act directly onto agent architectures. The agent receives a goal, gathers information, reasons about the best action sequence, executes, observes results, and loops. SOF applications include autonomous target package generation from a single tasking, same-night follow-on raids driven by AI processed captured media, and multi-stream pattern of life monitoring. The presentation cites 3 real examples. Project Maven automating ISR video analysis processing years of drone footage backlog in seconds. SOCOM's push to collapse sensitive site exploitation from months to minutes using AI at point of capture. And Ukrainian AI-guided FPV drones boosting strike accuracy from 3.050% to approximately 80%. The critical guardrail: agents are force multipliers for planning and analysis. They are not authorized to make targeting decisions, transmit operational information, or take actions with irreversible consequences without explicit human approval at each step. The SOF AI Synergies of Fast and Slow AI workshop explores the theoretical underpinning. System 1 fast, intuitive, and System 2 slow, deliberative cognitive architectures applied to AI agents. The dual process framework maps neatly onto the pattern emerging in practice. Fast reactive loops voice turn detection. Drone guidance paired with deliberative planning target package assembly, spec generation. Whether the cognitive science analogy holds up under scrutiny is debatable, but the engineering pattern of layered speed vs depth processing is showing up everywhere from voice pipelines to military kill chains.